Hi, Chris Kuzmal here. We're going to be looking at more test cases for the deletion helpers. And to do this, we're going to first understand that the insertion sequence dictates the structure of the tree. What does that mean? That means if we insert keys into a binary search tree, whose value are 0, 1, 2, 3, 4. That's going to give a different tree than if we insert the same sequence of keys in the opposite order or in an order which is, in this example, 2, 1, 3, 0, 4. Let's look at what we mean by that. If we insert 0, 1, 2, 3, 4, the first node inserted will always be the root. The next node inserted, if it's a 1, will go to the right because the root is 0. And then the next node that's inserted will go to the right because the root is 0, because its value is 2. And then it'll go to the right of the child node because its value is 1, and that gets inserted here. Similarly, 3 goes in, goes to the right, 3 compares to here, goes to the right, compares here, goes to the right, and lands here. And likewise, 4 slides all the way down to the right. And so the overall structure of a tree is branching to the right all the way. On the other hand, if we insert a 4 first, then 4 becomes the node, becomes the root. And 3 then inserts to the left, and 2 to the left of that, 1 to the left of that, and 0 to the left of that. And finally, if we insert node 2 at the beginning, then node 1, if that's the next one inserted, goes to the left, while if 3 is the next one inserted, that goes to the right, and 0 goes to the left twice to get down here, and 4 goes to the right twice. And so in each of those 3 cases, we end up with a binary search tree, which contains the same elements, 0, 1, 2, 3, and 4, or whatever order you want to describe them as, but they are not structured in the same way. Now, the thing is that this is good for our purposes of testing the 3 different kinds of deletion helper methods. The deletion, for starters, we're just going to look at the deletion helper method of scrub parent. And as you'll recall, if we scrub the parent of node 4 here, then that would cause node 3 to no longer point to it. So if we could do a sequence of insertion 0, 1, 2, 3, 4, and then a sequence of scrub parents for 3, 2, 1, then, and 0 for that matter, then all of those would be invocations of scrub parent if we were calling delete directly. But we don't have to call delete for delete to make the decision, because if we call delete, then we're testing the logic in the delete code as well as the scrub parent code. And so the goal here is to accomplish unit testing with an example which causes the scrub parent to behave the same way as delete, but that requires us to have a particular tree structure and to choose particular nodes successfully. Now then, so if we look at the actual code, the actual test code now, then we see, you'll recall we had the test delete helpers, and the first method was test scrub parent. Now there's these little arrows here, which are really cool in REPL, which allow you to compress your code. Actually, REPL is not the only case that does this. If I click on this arrow, it expands out the code, okay? And so we zoom in. And so test scrub parent that's just shows it, and then there's these dots over here that show that there's something inside of test scrub parent,